It's great to have you all here. I hope you are as excited as I am about the topics and the talks that we're going to cover today on this stage, because we're going to geek out and we're going to learn a lot together in this room. My name is Ed Marquez. I'm going to be your co-host or host and presenter. And before I get into the talks and all of that we're going to be covering today, I want us to remember why we're here. And we're here because we believe that we can build a better future with this technology. We can build a better future with Hedera. Today you heard from Mans and Lehman this morning, which is always energizing. And that energy is very contagious. You also know about this vision of anyone being able to carve out a piece of cyberspace and have a shared world with friends. And so, we're going to see with the work and innovations in this stage, how that vision actually turns into a reality. And the cool thing is that those innovations and that work come from all areas of the ecosystem, the Web3 ecosystem, the Hedera ecosystem. So today you're going to be hearing from an excellent group of community builders, an excellent group of open source experts, also engineers, product managers, and marketers, all who are a key piece of building and creating that better future that we believe we can create. And so let's dive into the first talk of the day with all of that in mind. And that talk is going to be covering the work that dozens of contributors and engineers do every month to empower our Hedera Builder community with amazing features and new capabilities. So I want to welcome to the stage also Richard Bair to cover what's new in Hedera in 2025. Welcome, Richard.
Thanks, Ed.
All right, Richard, so it says here you're the VP of Engineering, but I want to ask you, who is Richard?
Yeah, so I am Richard, hello. I lead the engineering team at Hashgraph. I've been from Hedera to Swirlds Labs to Hashgraph. I've been in all three of these different incarnations of the company. I'm also a member of the technical steering committee at the open source HYRO project, which we'll talk about a little bit later today. And yeah, I have the privilege of being able to work with some of the greatest engineers in the world, building the Hedera source code. It's all in the HYRO Linux Foundation project today. So that's a little bit about me.
Excellent. And I lead the developer relations team over at Hashgraph. So with that in mind, in this session, you're going to learn about the Hedera developments over the past year that fall in these areas of new hits and new use cases, so things that you can build with these new developments, also dev tools and integrations. We'll talk about that journey to permissionless, and we'll also cover open source, software, and community contributions. So starting with those new hits and new use cases that you can now tackle, one of the unique capabilities that Hedera has is scheduled transactions. And these allow you to automate and pre-plan these actions that require pre-approval from multiple parties. And so in the latest round of enhancements to these, you can now schedule transactions up to 2 months in advance. So that expiration limit went from up to 30 minutes up to 62 days, giving you a lot of flexibility for that pre-planning. And we also added the ability to execute transactions either when you receive all the signatures or at the designated expiration time. So that gives you even, again, more flexibility. And so what you see here is how you do that in practice. You have these two new methods in the SDK code that allow you to specify that expiration time up to 62 days into the future, and this other method to specify whether that runs right away upon receiving all signatures or at the time of expiry. And we also added, with these new enhancements, more transaction types for scheduled transactions, including contract create, contract update, and more to give you more flexibility and power with these tools. So again, scheduled transactions are there to build those applications that may require time delays, maybe multi-party approvals, and even recurring tasks, so you can automate things like value exchanges and payments and a lot more. Another very unique set of capabilities to Hedera is HTS. And so this also got an amazing round of improvements to help you build better experiences with this service. And so one thing that the community has been requesting for a long time is frictionless airdrops for native tokens. And so this gives builders that way to drive these airdrops, do these airdrops for large audiences in a very straightforward and simple way. And part of the enhancements here include unlimited auto associations of tokens to let your users receive those tokens directly into their account without that explicit manual step of the association. So this now includes 4 new transactions in the SDK to perform your airdrop, to claim the airdrop, cancel the airdrop, and even reject tokens to return them to the treasury, even if that token was received outside of an airdrop. Another enhancement in the area of the token service is dynamic NFTs to help you create those digital assets that adapt to changing conditions and or user interactions. And so what that means in practice is that now you have metadata at the collection level for both fungible tokens and non-fungible tokens. And of course, you also have metadata that you can specify at the serial number level, all of which are now mutable with that metadata key. Now, you may be wondering, I have a original collection. What if I don't have a metadata key? Well, you're still covered because with HIP 850, we added the ability to update the metadata for serial numbers with the supply key. So that gives users the ability to opt into these dynamic NFTs and the flexibility for creators to also update that metadata in a controlled way. And the third set of improvements for HTS include improved token management. So what that means is that the admin key can remove itself, or it can also remove other keys. So that reduces risk and uncertainty for your token holders and also gives you a lot of flexibility as a token creator. We also have the EVM, and with these improvements you're about to see, the EVM got more powerful and easier to use for your contract-based applications. So a big set of improvements here was support for the Cancun hard fork. And so this work includes support for new opcodes that support transient storage and memory copy. So what that means is that you now have the latest advancements of the EVM available to you on Hedera. We also added HBAR allowances and approvals directly through smart contracts. So as a developer, you don't have to change context working from your smart contract code and doing the allowances with Happy. You can do it all directly in Solidity and contract code. We also added this ability for you to authenticate signatures of any type, whether you have keys for any key, whether you have ECDSA or ED25519 keys. You can use the isAuthorize function for simple keys, which we all know very well. And you also have this other function, isAuthorize, for those multi-sig set of keys, whether it's a key list, a key threshold, and so on. And these two are in what we call the Hedera Account System Contract, or Hedera Account Service System Contract. And another system contract that you all know very well is the Hedera Token Service System Contract that also had some major improvements. One of those is the addition of these 3 functions, right? As you know, you can call HTS tokens as if they were ERC tokens. So all of those ERC methods work on your HTS tokens, and now you can even call these functions for this very specific type of capability, which is associations. So just gives you ease of use in your workflow with HTS. We also added atomic HBAR transfers for HBAR and HTS tokens. So in a single call, you can transfer all of these types of tokens. And this is fantastic because it supports those HBAR and HTS allowances while also honoring the native royalties on the Hedera EVM. So this is a game-changing feature for things like NFT marketplaces. And now you also have the ability to update HTS token fee schedules through smart contracts to have more dynamic and automated token management. So that is smart contracts, that is new HIPs and new use cases. Now let's dive into improvements to dev tools and integrations. And coming from smart contract development, you saw all of those improvements. A critical tool for any smart contract dev is the JSON RPC relay. And this relay now has a tiered HBAR rate limiter that helps operators manage cost and resources in a more sustainable and better way. So if you're not too familiar with this relay, what it does, it translates Ethereum JSON RPC requests into Hedera-compatible transactions and operations. And so the challenge here was that relay operators were bearing the cost of certain transactions that were involved in large requests. But now, with this tiered HBAR rate limiter, the operators can assign different spending limits to users based on that basic, extended, or privileged tiers that allows them to have more sustainable business models and cost management and serve their users better. And of course, the operators can also fine-tune the settings of this HBAR rate limiter to match their needs and better serve their customers with some reference documentation and guides here on the repo. All right, there's another tool that we all know and love, and that is Hashcan. And so Hashcan now has a refreshed, clean interface, and the best part is that it also supports dark mode, which we all know and love. And so Hashcan is always there. It's that interface, that gives you the information that you need in a refreshed and intuitive UI. Hashcan has actually seen some major improvements when it comes to supporting smart contracts. For instance, you can call functions for verified contracts. And you can also see the support for ERC smart contracts. So there you see the functions that you can call if your contract is verified. You can see the call out for contracts that are ERC, of ERC type. And so that gives you more flexibility to work with HTS, with ERC standards, and so on. Hashcan also improved the way that you have to manage your account preferences. So you can connect your wallet, whether it's a Hedera native wallet or MetaMask. You can update your staking preferences directly from the UI. You can associate HTS tokens. Even update your account preferences for the settings, and even approve allowances from the Explorer. And you can also see and claim any pending HTS airdrops that you may have for your account. And the last set of improvements for Hashcan relate to search and history functionality. So you can now search tokens by name. In this case, you see we're searching for USD, and you see USDC and Tether pop up as suggestions. And you can, of course, download your transaction history, which is tremendously useful for tax time, or if you're just curious about your account activity. Another tool that everybody knows and loves, if you're a Hedera developer, is the developer portal. And so now this has improvements that allow you to create accounts anonymously without having to go through the sign-up process with a faucet that gives you 100 HBAR every day by simply and creates an account for you by simply entering your Hedera EVM address. And we also made some improvements to the portal to reduce the frequency for testnet resets. We also added personal tokens, personal access tokens, and a portal API to enable you to access your portal credentials programmatically, which can be useful to automate workflows and even recover after those testnet resets. And a significant improvement to this developer portal is also the Playground, which is a game-changing tool that is right there in the portal to help you learn and experiment with the Hedera testnet just from a web browser. You don't have to install or set up anything locally. And so this tool actually supports both of the key types supported in the Hedera ecosystem, ECDSA, ED 25519. Also supports languages like Java and JavaScript, with more languages coming soon, and different Hedera services from accounts in crypto, HCS, HTS, scheduled transactions, contracts, and much more to help you learn, experiment, and test on the network. Now, learning and experimenting is very important, and we also have tools that I want to mention here that have seen improvements in the areas of testing and development. One of those is the Hedera command line interface. And this is for simplified execution and automation of multiple actions that deploy transactions to the Hedera network. And so this is a very simple to use tool that simply requires you to use either Node or NPM-based setup. Another excellent tool for local testing is local node, and this is for that initial development and testing of basic functionality with that local setup. And so this you can set up with Docker or the CLI tool. And for those more advanced testing workflows that want to reproduce or mimic a private network environment using Kubernetes, we have Solo for you available.
There's also, Ed, for Solo, there's a GitHub action that you can use. So if you have your project, the Python SDK is using this, some of the other SDKs are using this. If you have a project and you're doing some sort of development and it's on GitHub, you can use the GitHub action, and it'll automatically deploy a solo environment, have all the environment variables available for you so that you can actually use that environment for your testing. So there's a nice streamlined way to use solo in your GitHub actions.
Excellent. All right, another area of major improvements relates to integrations and infrastructure. A lot of these names were not here 24, 12, or sometimes even 6 months ago. And so these are a lot of the new integrations and infrastructure that is now available to you to build on the Hedera ecosystem. Now, for this part, I want to let Michael and Greg tell you all about it, so be sure to check out their talk on projects and integrations to watch on the Hedera ecosystem. That's going to be at the main stage at 5 p.m. All right, now let's go over the journey to permissionless. Richard?
We'll switch your spots.
Let's do it.
Take your little, forward. So I'm going to talk about a few of the different things that we have been working on, in particular things that we need to do, sort of groundwork pieces in order to get to a permissionless network environment. And one of those is something that we've been working on for a while now, which is called the dynamic address book. And it was really a fundamental series of changes that we needed to make to the underlying consensus software that would allow us to change which nodes are part of the network dynamically. And there are several different parts that go into making that happen. The first was introducing an API at the happy level that would allow us to manipulate, the different nodes that are in the address book, what we call the address book, which is the list of all the different nodes, their endpoints, and other information about them. And then, so that was our stage one. Stage one of this process was we need to develop a Hedera API, and so that we can start storing this stuff in state. It's available through mirror nodes, through queries, those sorts of steps. Then the second step of this process is to make it so that these address book changes are used dynamically at the end of each day. So our staking period is once a day, where we pay out rewards and so forth. And that would be the moment when these new nodes will become available. Today, the changes to the address book take place when we do an upgrade to the network, so it's once a month. But in the future, we're working on stage 2 this year very actively that will allow it to take effect within 24 hours. This is one of those sort of fundamental pieces you need, because if you're going to have a permissionless network, somebody decides that they want to join the network, they have to have an API to say, here's my node, I would like to join the network. There needs to be a way for all the different people in the network to be able to stake to that node so that it has a stake weight associated with it, and then there has to be a way for that to become effective immediately. The other part about dynamic address book that's important is from a safety and security perspective, it's actually to pull somebody out of the address book if it turns out that they're malicious. Whenever you're dealing with a permissionless system, you always have to be thinking, what happens if somebody is not honest? What do we do with them? And so being able to pull them out more frequently than once a day is also important. So the dynamic address book feature is actually has two different timetables on it. One is we can add new nodes in on a daily basis. The other one is we can remove nodes almost immediately if they turn out to be malicious. So there's a lot of interesting work that's going on around dynamic address book. Oftentimes, you may see this abbreviated as DAB in our GitHub issues, but that's the dynamic address book. Another big feature that we're working on, this one is, I don't know, we're probably 14 months into this one. It's a massive, massive change to the overall structure of the system. And today, the way that this works is that we have our consensus nodes, and there's a bunch of them that they gossip together, and you have these transactions that come into the consensus nodes, and then they produce a whole pile of outputs. There's these outputs called safe states. They take basically whatever the state was on the nodes and they output those. They have this account balance file used to be produced. We don't produce it anymore, but we used to have that where it was just the account balances that got exported. Then we have another one that has the events, which is an event is sort of an intrinsic part of the Hashgraph algorithm. So those guys would get exported, and then we had what we called our record files, which is, this part is essentially the blockchain that was being produced, and then we had all these sort of ancillary files being produced. And then we were storing all those things into a combination of Amazon and Google buckets. And then the mirror nodes would consume the stuff that came out of that. And initially, when we were looking at this problem, we thought, well, we have two problems with this. The first one is this isn't very decentralized because we have two big cloud providers and that's it, that are storing our blockchain history. That doesn't sound very good. And the other problem we had was that operating these mirror nodes are fairly expensive because they have to pay these guys to download those files. And if you wanted just a subset, one of the things a mirror node does really well is it allows you to take just a subset of the entire history. So that if your mirror node was just for your application, it could just store only what's new for your application, which would make it a lot cheaper to operate, except there's one catch. It has to download everything from here in order to filter out just what it wants. That was problem number 2. Those were the 2 problems that we wanted to solve. And so Jasper Potts put a lot of thought into this, and he said, I think that we can streamline this. What we can do is we still have our transactions and stuff coming into the consensus nodes, but now they're going to produce a new type of a stream. We're going to call it our block stream to make it very clear that these nodes are producing our blockchain. And this block stream will be a stream of blocks and items within a block that get sent to a new type of node, which is a completely permissionless node called a block node. And this totally replaces the Amazon and Google component that we saw before. Anybody can operate one of these block nodes, and it stores the history of the blockchain. And we will have some of it backed up into some archives, but it's also going to be able to stream to mirror nodes or other block nodes or other apps. We have a whole talk on block nodes later this afternoon. I think it's 2 p.m. And we'll go over this in detail. But it just solved so many problems for us. In fact, it became kind of a joke inside the company. Every time somebody would say, hey, I have this problem, and we'd say, yeah, block nodes will solve that. So this is a major change to the way that our system operates, and it really up-levels the concept of a block. And these blocks have such incredible power. You'll have to come a little later today to find out more about that. But these are kind of some of the main key benefits. We will have lower latency access to the data. We'll be able to produce state proofs and block inclusion proof from those blocks that are produced. It gives us better decentralization. And it's also going to enable this. This last bullet down here is a very important one that I'm not going to go into detail in this discussion, but in later talks we'll cover this. But we're working on a fully asynchronous Byzantine fault-tolerant interledger communication system that's going to be built on the proofs that come from these blocks. And this is going to open up a ton of additional use cases for us with all the same sort of safety guarantees that you have from Hashgraph. Basically, if you have 2 ledgers that are both ABFT, the communication mechanism is also ABFT, and you have that level of security across all of them. So this is the talk that we have later today, where Jasper and I are going to go over it. It's an hour long, so we will have a reasonable amount of time to go into some detail on what these block nodes are. Another one of the things that we put a lot of effort in was modularization of our consensus node code base. And it's sort of a very geeky thing that most people, you don't look at modularization and say, what sort of features did I get out of that? But it was an important piece of work that we did that actually makes it a lot easier for people to construct, to participate in the open source development, which we open source this to Hyro. Having the modularity makes it a lot easier to participate. But also, we're opening the door for building sort of custom services for custom nodes. You may have heard of that, this idea of being able to fire up new networks, the private networks or personal networks like a Sphere. And modularization is like an essential prerequisite for that. So there was a lot of work that went into this that we released earlier this year. This actually, as an engineer, like if not with a product hat, but an engineer hat, this is one of those things I'm personally extremely proud of the team for. You rarely find people who take a working system that's in production with billions of dollars riding on it and then swap out the whole chassis and nobody even knew. It just worked. It's a very difficult thing to accomplish. I'm very proud of my team for being able to do that. Incredible, incredible work. All right, and then the last section here, open source software community contributions. So we heard this morning in the keynote a little bit about this step. It was on Mance's slide about open sourcing the Hedera software under the Linux Foundation in Project Hyro. This is something that we worked very hard. One of those things behind the scenes, nobody saw it until the announcement came. It's a lot of hard work that went behind this. It was very intentional. We evaluated many different ways that we could manage the the source code. Like, how are we going to build an open source community? And we felt that the Linux Foundation was the ideal home for us. The Linux Foundation is incredibly supportive of open source projects. It's not like a top-down, thou shalt sort of organization. It's a bottom-up, we are here to support you type of organization. And they have a tremendous amount of support that they provide for us, and also a lot of outreach. The Web 2 community is very strongly associated with Linux Foundation, as are all of the different companies that are out there, the enterprise companies. So it opens a lot of doors for us and gives us an opportunity to build a much larger and richer community. It also means that we have really good governance over the source code itself. Just as the governing council governs the Hedera network, Hyro governs the source code that's developed for the Hedera network. On that, there is a technical steering committee, and we actually have 3 open positions that need to be for elected representatives. And I'll talk more about this later as well, or if you find me out in the hall. One of my main missions this week is to recruit as many new voters and people who want to run for one of these positions on the technical steering committee. It's open to everybody, and it's just based on meritocracy. This is a normal meritocratic-based open source project. So, the open governance, come join the TSC, contribute code, contribute documentation, anything you want to do. Our meetings are public. They're available. You just join a public Zoom. You can be part of any meeting that we hold. So collaboration is one of the key things behind the reason that we open sourced our stuff and moved it under the Linux Foundation. And today, the full consensus node software and the mirror node and the block node, which is not yet completed, but we're working on, is also there, along with our SDKs and some other projects. So there's a lot of great stuff that's already out there in Hyro. So I encourage you to participate, go look at the code, ask questions, join the community calls, and so forth. It's really about this collaboration. It's about adoption, leveraging the reach that the Linux Foundation has. And then all that innovation that we're building is all being done right there in Hyro. Every HIP, the Hyro, there used to be Hedera improvement proposals. Now the Hyro improvement proposals. Luckily, we didn't have to change the name. Still a HIP. That now is actually goes to the TSC for approvals to decide, is this something that we're going to build, and then it goes to the Hedera Governing Council to see if they will accept it onto the network. So you have these 2 different governing bodies, both of which are decentralized, both of which are available to people to participate in. So that's our open source. In terms of sort of action that can be taken, I've got some QR codes up here. You can nominate for candidates to represent you on the TSC. You can join our community calls, find a project to contribute to, or visit our website and help spread the word.
Another set of open source tools that came out over the past few months and the past year include these 5 accelerators that help speed up your development with pre-built components, with templates, with best practices. And so one of those is Stablecoin Studio to help you issue and manage stablecoins on Hedera in a matter of minutes and hours rather than days or weeks. So be sure to check that one out. Also, very recently, we released Asset Tokenization Studio to help you asset or tokenize any type of asset, real-world assets and so on Hedera. So it includes a set of contracts that make this process very easy. We also have the Guardian, which is your workflow policy engine to issue and manage your assets when it relates to green finance and sustainability. And there's also NFT Studio, which includes a handful of tools to help you manage everything related to the life cycle of your NFTs, from a risk calculator to a airdrop list, to give you your token holders, and so much more in that area. And finally, there's also Hashio DAO to help you form DAOs very easily on Hedera. When we think about what's next, Richard.
All right. So these are some of the things that are on our wish list, some of the things that we are working on, actively working on, or things that we would like to be working on even more, and opportunities for people to participate. So one of the top things on my mind is this concept of on-chain programmability and just taking that completely to the max. Dial dial that thing up to 11. Because like Ed was saying, right, he was showing on one of those slides, all those different things that were being added to the Hedera account service system contract and things like that, that it give you more power and expressivity in your smart contracts. We just want to take this as far as we can. We want to make it so that all logic that's on chain is logic that anybody in the world can look at, review, audit, and ultimately trust. We want to make that a big part of our system. As Lehman said this morning, trust, right? This is about trust. So being able to take that to the max is really important to us. That includes things like performance and includes things like scalability, more gas per second, all these sorts of things. We're always interested in performance. We have ideas and plans and concepts that will get us to faster finality, lower end-to-end latency, hoping to be able to deliver on that. Batch transactions and jumbo Ethereum transactions are two HIPs that are currently being worked on. Jumbo Ethereum transactions closes one of those little inconsistencies between Hedera's EVM support and Ethereum. So that's a really important one. As are lower cost JSON RPC relays, that's a really important one as well. Block nodes that I talked about, it's already open source on Hyro. Development is active on that. Python SDK, this one was completely developed and supported by open source community, which is kind of unique relative to our other SDKs. And this is a great place for people to come in and participate. We have a comprehensive TCK. The TCK is a technology compatibility kit, and you can use it to verify whether your SDK implements all the features correctly or not. And we're just making that thing even more comprehensive so that we have a really, really rich test set that tests everything end to end. And then we have all these new features that are coming as a result of block nodes, the block proofs and state proofs and block item proofs, and then this interledger communication. Those are all things, I'm not saying that this is all getting done this year, folks, but it depends on what kind of involvement we get from people. We will work as hard as we can on these things, and the more the merrier. There's a lot of room in here for collaboration. That's why we did Hyro, so we'd love to have you come and join us.
Amazing. So today you learn about the major Hedera developments that have happened over the past year in multiple areas. And just to do a recap here, you saw how you can build better solutions with scheduled transactions, with improvements that happen for HTS and also the Hedera EVM. Then you saw that Hedera gives you those powerful tools to build, to test, to learn, to experiment, and ultimately get to production. And those included improvements to the JSON RPC relay, to Hashcan, to the portal, to the playground, and so much more. And also Richard covered these fundamental steps that we have to take in that journey to a permissionless network, including the dynamic address book, block streams, and modularization. And finally, when it came to open source, you saw that Hyro, the accelerators, the community are a key component of that open source philosophy that Hedera embraces. So that is all for today. We want to thank you for your time, and we really hope you enjoy the conference. So thank you.